Hey, hey you behind the screen. Thanks for watching. So now we are on video 2. Thanks for watching. Boom. So we're going to go ahead and do inequalities now. So inequalities, still absolute value, very similar, but you just have to change 2 things. So we're going to do x plus 2 is greater than 7. Drop the absolute value symbol. There we go. So x plus 2 is greater than 7. And we're going to have to do x plus 2. But this time, we're actually going to be changing 2 things, right? We're going to be changing, let's double check. Yep, change the sign. So we're going to be changing 2 things on these ones, okay? So we're actually going to be changing 2 things. We're going to change, wrong color, buddy. We're going to be changing the inequality symbol. So instead of greater than 7, it will be less than. And then the 7 as well, we're going to change that to a negative 7, right? So now that's going to be our new problem that we're working with there. And so now we're going to go ahead and minus 2. Good, good, good. We're going to minus 2 to both sides. So we get x is greater than. 7 minus 2 is 7. Minus 2 is 5. That's one of our solutions. So x is greater than 5. And then minus 2, we get what? X is less than 9. So that gives us our 2 solutions. You have to change the sign and the number to get all the solutions for this inequality to work properly. Now, don't forget that greater than, less than is a open hole. Remember that? Open hole. And so that would be like filling in there. Right? Open hole. If you're graphing, filling an open hole. This is just for graphing purposes. Remember that? So it's going to be a... Oh, no, that's filling the whole new bullet. What are you doing? What are you doing? That's already ready to go. It's an open hole. Sorry. But, oh, greater than, less than, greater than equal to, less than equal to, then is the closed hole. And so with the closed hole, then you would fill it in. Cool. Just important when you're doing graphing. I don't think you have to do number line graphing. Maybe on the test. Maybe you're ready to do that. Okay, so we're going to check and make sure this works using our number line anyways. So we're going to go ahead and do 5 and 9. And so we're going to do an open hole at 5, open hole at 9. And so we want all numbers x. Remember, that's what that stands for. All numbers x. Right? So all numbers greater than 5. So think about it. Think about it. So what's greater than 5? 6 is greater than 5. 6 is greater than 5. 7 is greater than 5. 8 is greater than 5. What's going on here? 9 is greater than 5. Interesting. Did I make a mistake already? X plus 2 is greater than 7. And then x plus 2 is less than negative 7. Oh, Newbold. What did I forget? What's negative 7 and a negative 2? Newbold, it's a negative 9, you silly Billy. Because I was wondering what was going on there. Okay, so we have x is greater than 5, and we have x is less than negative 9. So now I've got to go ahead and move my number line a little bit. That's okay. Move my number line because it's supposed to be a less than negative 9. So we got a 0 in there. So yeah, so now it's going to be all numbers greater than 5 and all numbers less than negative 9, like, like negative 10, negative 11, negative 12. Now let's just make sure this works, okay? So let's just choose a number. Maybe 6 should work then if it should work. So we'll plug it in. Ready? So 6 plus 2. 6 plus 2 is 8. And is the absolute value of 8, is that greater than 7? Yes, it is greater than 7. Check. So 6 works. And 7 plus 2 is 9. That works. 8, yep, so forth. So all these solutions, infinite number of solutions works. So that's going to be one of our answers. But let's look at the symbols now that they give us, okay? So they give us x is less than. They give us x is greater than. This is the prompt in Canvas. So we're going to do x is greater than. We just did x is greater than 5, and it worked. So we'll type a 5 in there. And there's your statement now. X is greater than 5. X is less than negative 9. So if we plug a number less than negative 9, like negative 10, it should work. So negative 10 plus 2 is negative 8. And, but you do the absolute value, remember, the absolute value of negative 8 is a positive 8, which is indeed greater than 7 again. Nice. So yep, our answer is negative 9. So I'll try to go a bit faster with the other ones if you're just wanting to check your answers on these videos. But definitely wanted to remind you how to do inequalities if you forgot. So remember that grade tour. Thanks, Parker Merkley. Shout out to my student teacher from last year. So greater than, right? Greater than. So grade tour means, are you going to the beach? Which way is to the beach? Is it this way or is it this way? And that's what we had with the previous problem, right? In opposite directions. This one will be an open hole. Okay, so we're going to go ahead and split this again into two equations. We got x minus 4 is greater than 5, and x minus 4 is less than 5. Oh, less than negative 5, right? Because you got to change the sign. And, oops, you got to change the sign and the inequality. New bold, make sure, you too. Okay, so now we're going to just simply add 4 to the other side. So x has to be greater than 9. And add 4, x has to be less than negative 1, right? Negative 5 and 4, make sure we did that right. It's okay to make mistakes, just got to fix it, right? Just check your work. Okay, so x is greater than 9. Let's see, like a number, for example, like 10 maybe. That's greater than 9, just to check your answer. Just to check our answer. So 10 minus 4 is 6, and 6 is greater than 5. So that works. Okay, so we're going to say all numbers x is, where's greater? There's greater. So x is greater than 9. Okay, and then less than negative 1, like negative 2, for example, maybe that works, or negative 3, or negative 4, negative 5, negative 6. So plug a negative 2 in. Negative 2 minus 4 is a negative 6. And the absolute value of negative 6 is a positive 6, which is greater than 5, So that works, so we'll put a negative 1 in there. Okay, there's number 11. Number 12, doing some more inequalities. So this inequality this time is actually going to be, right? So it's actually going to be a less than, so less. And that's a little bit different. It's a less than, right? That's a less than or equal to. But let's call it less than. And the reason why is when you go to graph it, and it's an equal to, so that's a solid dot, and it's solid dot. And since it's less than, that means it's going to be everything in between. So instead of going opposite directions, you're going to go towards each other, right? And everything in between. Okay, so we'll go and split this off into 2x minus 6 is less than or equal to 12. And we're going to do 2x minus 6 is greater than or equal to negative 12. Remember that? Change the sign and the symbol for the second equation. Okay, so now we'll go and add 6. What is 6 plus 12? 6 plus 12 is 18. And then bring that down. We haven't divided by a negative yet, have we? No. Okay, good, because you might have to flip the inequality sign, remember, when you divide by a negative. So divide by 2, x is less than or equal to 9. And then over here, we're going to go ahead and add 6. And so when we do that, we get 2x is greater than or equal to negative 6, right? And then divide by 2. So we get x is greater than or equal to negative 3. So those are potentially our answers. So x is less than or equal to 9, x is greater than or equal to negative 3. And let's see here. So then we do a little number line with negative 3 and 0 and 9. So it's saying all numbers less than or equal to 9, that's this direction. And then all numbers greater than negative 3, that would be this direction. Nice. So then let's plug in a number like 0 and see if that's true. I love 0. Plug in 0. 2 times 0 is 0, so it just goes away. And then the absolute value of negative 6 is a positive 6, which is less than or equal to 12, which works. So type in our answer now carefully. Ready? So again, it's negative 3 to 9. So what that's going to look like is negative 3 and 9. All the numbers are in the middle. And then all the numbers are going to be greater than or equal to negative 3, but less than or equal to positive 9. So we'll plug in a negative 3 here and a positive 9 there. Beautiful. There's number 12 to check your answers. Okay, so here's number 13. So we're going to go ahead and square both sides. Square both sides. Oh, we got to do anything weird? Nope, it's just more radicals. So we'll just have you check your answers. So x minus 2 equals 5. 5 squared is 25. Didn't we do this problem already? Add 2, we get x equals 27. This looks familiar, right? 27 minus 2 is 25. And the square root of 25 is 5. 5 equals 5. It works. So again, we're going to say 27 is our answer. And then don't forget, lowercase, none. Number 14 is definitely one that a lot of students missed on the 1.3 quiz. So let's go ahead and do that one and be more careful this time. Really show you how to do this one. Okay. So we are going to go ahead. We're doing radicals now, which is different. Different than absolute value. That's different. Now remember, if you square one side, you have to square the complete other side. Complete other side. What do you mean, Newbold? This complete other side. So what I mean is that's gonna get rid of that. So 1 minus x equals, right? The square gets rid of the radical. But now we have 5 plus x. Don't need that arrow, I guess. 5 plus x times 5 plus x. Right. So now you got to FOIL that sucker out. You have to do 5 times 5 is, I'm actually going to put it here, is 25. X times x, remember the i's, is x squared. Then, this is where people make mistakes. They stop there, but that is not correct. You've got to continue multiplying, FOILing it out, right? This is the inside term, FOI. This is the inside term for FOIL. So that's 5 times x is 5x, and then the outside is 5 times x is 5x. Good. So now we'll bring down that 1 minus x. We'll combine those and make it a 10x. I just bit my lip, and it really hurts. Thanks for feeling bad for me. You ever do that at the Worth? When you're talking and bite with your lip. Okay, get everything on the same side is the next step. Do you remember that? Get everything on the same side. So now we have 10x plus a 1x by itself is 11x. And then we're going to minus 1. We're getting everything on the same side now. And so that's going to be a 24. And then an x squared. Now, do you remember what you have to do next? Can you remember? We have two solutions. How do we get them? We factor it. So we get x and x, and then factors of 24 is 8 times 3, 6 times 4 works, but not to get 11. We've got to get that 11 there. And 8 plus 3 is 11. 8 plus 3 is 11. So we get two solutions. Set them both equal to 0. Remember this part. So we get two solutions. Remember, it's opposite what's inside the parentheses. So not a positive 8 and a positive 3, but rather a x equals negative 3, right? So we get x equals a negative 3 as well as the negative 8 when you minus it to the other side. Okay, so now we want to plug it back to the original. I have a sneaky suspicion that one of these is probably extraneous. Remember, you got to plug it back into the originale. The original. Okay, so square root of 1 minus x equals 5 plus x. Good, good, good. So now let's use a different color. Kermit the Frog here. And Piggy. We're going to use green. And so now we need to go ahead and plug each of these in to make sure it works. So you plug in a negative 3. 5 minus 3 is 2. That's looking promising. Ooh, put a negative 3 in here. Well, a negative times a negative is a negative times a negative is a positive. And 1 plus 3 is 4. And the square root of 4 is 2, which equals 2. So it works. Green and blue. Okay, there we go. So that works. So the 3 definitely works. So we'll put in a negative 3 right here. But I have a sneaky suspicion. about the 8, right? because when we plug a negative 8 in there, ooh, what's 5 minus 8? It's negative 3. Will a square root ever yield a negative number? No. This is 1 plus 8, which is 9, and the square root of 9 is 3, does not equal negative 3. So this is your extraneous solution. So how you're going to enter this in to Canvas with your blue end, I don't know. So how you can enter this in Canvas is that negative 8 is the extraneous solution. And now for your second solution, you're actually going to need to put none, all lowercase, because it's extraneous. And so then you'll get full points on this problem on the test. Nice, nice, nice. Okay, number 15, don't have two solutions, just the one. This will be a pretty fast one. Ooh, but I don't know about that 6 there being on the other side. Right. So before you solve it, before you can power 2 both sides, you actually have to deal with the negative 6 first. Get everything over to the other side. Everything. Right? Whether you have to divide it to the other side. So everything over to the other side, to the other side, to the other side. So you basically need to isolate, right? You need to isolate the radical. So we're going to minus 6. That's going to give us a negative 4. That's not looking promising. Okay, but we'll still go through it to find the extraneous solution. We'll go and square both sides. So then we get x minus 4 is equal to negative 4 times negative 4 is a negative times negative is a positive 16. And then we'll add 4 to both sides. We get 20. X equals 20. So worried about that one. Let's see. So we're going to plug it back into the original. So we're going to plug it back in here. So 20 minus 4, so 6 plus. 20 minus 4 is 16. That's good. That's good. And then the square root of 16 is, square root of 16 is 4. 6 plus 4, that doesn't equal 2. Extraneous. So that means we don't have a solution. Well, we do, but it's what? It's extraneous. So that's how you deal, remember, with the extraneous ones. So put your answer as none, and then put the extraneous solution as 20. Beautiful. Okay, so there's number 15. Here's another one. We'll do this one really fast because this one looks a little bit trickier, but we've already done quite a few of these. So let's see here. First of all, we're going to minus that 2 to the other side so that we get 6 minus x. Then we'll power 2 both sides. Everything power 2 both sides. So we get 6x plus 4 equals, remember there's 2 of them. That's going to be fun. So that means there's 6 minus x times 6 minus x, right? So then we're going to FOIL it. So 6 times 6 is 36. Negative 6 times negative 6 is a positive x squared. And then we have negative 6x. I'm going to combine steps now. With another negative 6x is going to be negative 6x is going to be a negative 12x. Skipping some steps because we've already done this type of problem. Okay, so now we're going to go to minus 4. Don't know why it's going green and blue on me. Sorry. We get 32. Then you're going to also minus 6x. We're getting everything on the same side. So now we get negative 18x. Good, good, good. Then we're going to go and factor that puppy. So we get x and x. What are factors of 32? 8 and 4, 8 and 4. But 8 and 4 does not equal 18. What about 16 times 2? That's 32. Good job. So both are going to have to be negative. Both are going to have to be negative to reach negative 16 with negative 2 is going to give us that negative 18. So set them both equal to 0, and we get 2 solutions that are not negative. It's a positive 2 and 16. So then we plug that back in the original to see if it actually works. So if we plug in the 2, 8 minus 2 is 6. So that's going to work because you'll minus 2 to the other side. You'll get a 4. And then we'll put a 2 in here. 2 times 6 is 12. 12 plus 4 is 16. Square root of 16 is 4. 4 equals 4. It works. So 2 is definitely going to work, but I'm not so sure about the 16. That's just a huge number. It's a huge number to put into this negative. And then when you minus the 2, you're going to get a stinking negative 18. And then 8 minus 18 is going to be a negative 10, right? And so on this side, I'm guessing you'll get a positive 10, because 16 times 6 is 32, 64, 96 plus 4 is 100, and then you square root the 100. Yeah, you do get 10. So 10 does not equal negative 10, so that's a big fat none. And then it is an extraneous solution, 16. Making sense, you guys? I hope this is making sense. Hope you guys are acing these. There we go. We got some more radicals to bust through. Maybe some new ones. This one's pretty dang easy. We'll do it real fast. So minus 5, 4 minus 5 is a negative 1. So then don't forget to now, once you get the 5 over there, then you can square both sides. Notice the 5 plus there, that means to minus it then. Some people are confused with this guy, right? When you get this guy, that's different. That's different. You'd have to divide the 5, right? We have a plus there, so we're minusing it. We're minusing it. Okay, so square it, positive 1. The radical goes away. We'll go ahead and minus 3 to both sides. So then we'll get negative x is equal to negative 2. Now we have to divide by that negative to get it to the other side, a negative 1. And so that's going to give us a positive 2. And I'm pretty sure that works. Let's try it. So we'll plug a 2 in. Whoa. So 3 minus 2 is 1. Oh, what the devil? Is this not going to work? Ooh, let's double check this one. Did I go too fast? Did I go too fast? Minus 5, that's negative 1. Good. You square both sides. We got a positive 1. Good. Then we minus 3. What's negative 3 with a 1? It's a negative 2. Divide by negative 1. So you do get a positive 2. So then when you plug it in, 3 minus 2 is 1, square root of 1, which is just 1. And 5 plus 1 is 6. And 6 does not equal 4. 6 does not equal 4. So this is a none in the end. This is a none, and the extraneous solution is 2. That was a fun, tricky one. Oh, I guess if you minus the 5 over, yeah, it's a negative 1, and the square root will never become a negative number. So that makes sense. Okay, ooh, beautiful. So this one, you are going to square both sides. It's ready to go. Radical on one side, radical on the other side. So you're left with x squared minus 10 is equal to 2 minus x. Now you want to, because of the 2, you're going to have 2 solutions. So get everything on the same side, remember, and factor it. So we're going to add x to this side. They don't combine because they're different creatures. So just add x next to it. And then we will minus the 2 and get a negative 12 there. So we got everything on the same side. Now we're going to factor it. So we get, what are factors of 12? It gives you a difference of 1. 3 times 4 is 12. Remember that the sign of the middle term goes with the bigger number. So we'll make that positive. And 4 minus 3 is 1. So that worked. Setting m equal to 0, setting m equal to 0. We're going to get 2 solutions. We're going to get a positive 3 and a negative 4 when you minus that to the other side. Okay, so then we plug those in. And maybe one of them doesn't work. We'll see. Let's see here. The answer is, so we're going to plug a 3 in. 3 squared is 9. 9 minus 10, negative 1. That's not going to work. Bump, bump, bump. So that's our extraneous already. Just found it. Because if you plug a 3 in, 2 minus 3 is negative. I guess they equal each other, but they're imaginary. That's ridiculous. I don't know. We should check the answer on this one, right? Because that's kind of weird. Oh, but if you do plug a negative 4 in, it should work. Because negative 4 squared is 16. And then 16 minus 10 is radical 4, which is just 2. Plug a negative 4 in. Wait a sec. 16 minus 10 is not 4, it's 6. So plug it in there. Negative 4 squared is 16. 16 minus 10 is 6. And then in this side, you get negative negative is a positive, so that becomes positive. 4 plus 2 is 6. Yeah, so definitely, the negative 4 works. I'm thinking we're going to say 3 is extraneous just because there's not another place to put your answer, right? So if you get it wrong, then, ooh, sorry about that. Maybe it was supposed to be that because you get, that does work, kind of. I don't know. Ooh. Try it like this first. Sorry about that weird one. We'll check on that in class before you take the test if you really need. Okay, jumping over to number 19 in the house. Oh, crap. What just happened? Do you see the web page every time you file? Go away. What are you doing? Go away. I don't like you. Go away. What are you? Why are you doing this to me? There's so many of them. Oh, just a second. My thing's freaking out. We'll pause the video so I don't take up more of your time. Are we back? We are back. Okay, there we go. Thanks for watching. Okay, so then let's see here. So number 19. So we just got to get it to the other side, and then it's the very exact same problem as the other one we just did with factoring and stuff. So radical x squared minus 1. So we're going to add radical 5x minus 5. Right. We're going to add that to the 0. We're going to add it to the other side. And so when we do that, we do equals radical 5x minus 5. And now we can go ahead and square both sides. So we get x squared minus 1 equals 5x minus 5. Get everything on the same side. So then we minus the 5x to the other side, and we add the 5 to the other side. And then that 5 minus 1 is 4. Factors, 2 and 2, that's not going to work. No, quadratic formula. No, 1 and 4. 1 and 4 will work, both negative. Okay, so then, remember, don't just sit here and copy this down. You're going to fail the test unless you try on your own. So go ahead and pause me, and next time, or right now, or throughout the video. So pause me, try on your own, then push play, and then watch me, and see how you did. Right? No point in just copying, because that's not going to help you on the test. Okay, beautiful. So now we're going to go ahead and, we have 2 solutions there. We have x equals 1 and 4. Let's see which one works. Maybe they both work. So now we're looking again at the original there. We're going to plug a 1 in. 1 squared is 1. 1 minus 1 is 0. And then 5 minus 5 is 0. 0 equals 0. It works. So one of our answers does work. It's 1. Now let's plug the 4 in. 4 squared is 16. 16 minus 1 is radical 15. Now plug the 4 in. 4 times 5. 4 times 5 is 20. And 20 minus 5 is radical 15. And so we have radical 15 minus radical 15, which equals 0. So we have 2 solutions, 1 and 4. And then remember to put none if there isn't a solution or if there isn't extraneous, right? Okay, there we go, number 20. And then we'll probably do the next video because this takes up a lot of time there. You've already seen something like this. However, there's 2 steps to doing 3 steps. So initially, you got to do a few steps. So we're going to minus 8, get that over to the other side first before we can deal with the absolute value. So that gives us a 5. Now because it's next to it, that means times. So remember, pause me. If you don't know what you're doing, give it a try first. And then, don't just watch, don't just copy. So 2x minus 9, still the absolute value, is equal to 5 times 5, or 5 divided by 5, which is just 1. So now we're going to have 2x minus 9 is equal to 1. We're going to split it into 2 equations. 2x minus 9 equals 1, and 2x minus 9 is equal to negative 1. Nice. Okay, fraction. We feel a fraction come in. Okay, so now we're going to go ahead. I wonder if it's a decimal or a fraction. I feel like on the test it'll be a fraction, but it might be a decimal in this problem. So we're going to go ahead first, and oh no, we might be good, because we're just going to add 9. So 9 plus 1 is 10, and then divide by 2, we get 5. 5 is one of our solutions. Add 9. 9 minus 1 is 8, right, is 8. And then we go ahead and bring down the 2x and divide by 2, divide by 2. Then we get 4. So we have two solutions, 5 and 4. Let's see if those work, though. So 5, 2 times 5 is 10. 10 minus 9 is 1. So then we have the absolute value of 1 is just 1. And 5 times 1 is just 5. So then we have 5 plus 8 does, in fact, equal 13. It works. So 5 is one of our solutions. Maybe put it over here just in case. I don't think numerical order matters, but you never know. We're going to plug a 4 in. 2 times 4. 2 times 4 is 8. 8 minus 9 is a negative 1. But the absolute value of negative 1 is a positive 1. Times that by 5. Add that with the 8. 5 times 1 is 5 plus 8 is 13. It works. So both of them work for number 20. And then the extraneous is none. Extraneous is none. Okay, number 21. So, very similar, but still, we got to go ahead and minus the 12, do the other side first. So we get a negative 27. Then we have to divide by the negative 3, right? Divide by the negative 3, so we get a positive 9. So I just did a few steps really quick there because we're running out of time on this video. And so now we can go ahead and split that into two different absolute value equations. So we're going to have x plus 9 equals 9. That's unusual. And an x plus 9 equals a negative 9. That's unusual. Okay, beautiful. So 27 divided by 3 is 9. Yep. All right. So I guess we're going to minus it over, and x just equals 0. That was funny. Okay, and then we'll minus it over, and the other we get is negative 18. Ooh, I wonder if they both work or not. Okay, so let's see if 0 works. That's my favorite. That's my favorite. That's my favorite. So we'll plug in a 0, and then the absolute value of 9 is a positive 9 times negative 3 is a negative 27 plus 12 is a negative 15. Interesting. So 0 does work. 0 works. What about a negative 18? What about negative 18? Well, negative 18 plus 9 is a negative 9. But the absolute value of negative 9 is a positive 9 times negative 3 is negative 27 plus 12. Yep, it works. So we have negative 18 as well and none extraneous. Okay, watch my last video. Thanks for watching. This one was way too long. Sorry about that. Thanks for watching. Hopefully you're just fast forwarding through it. Thanks for watching. The last one will be really short. Thanks for watching.